This video is an introduction to the summer homework assignment packet from 2012. I'm not going to talk through everything that's in the packet here in this video because some of them deserve a little bit longer explanation, but I wanted to get something out there to get going. So there's the introductory letter here. Connect with me somehow, Facebook, Google+, I would recommend. If not, make sure you're connected with someone who is. That way, as I post videos or other information this summer, you can get them. I'm working on a chemistry webpage and really just need to decide on a site and start getting stuff posted there. But there should be a decent amount of information coming your way here soon. Anyway, read through the letter. I won't insult you and read it for you, but please do read that. The next thing in your packet was a black and white version of this periodic table. You would have also received a color version of it separately. This is from Ed Esquardo, who is a chemistry teacher down in Cincinnati. Absolutely phenomenal version of the periodic table. I heard him give just a brief talk at a conference a while ago, and this periodic table just has all sorts of great information on it for you. Unfortunately, you won't be able to use this periodic table on your test, and the AP periodic table is incredibly boring and simple. It's like this, but I give it to you because it's a great tool, it's a great resource to get you started and help you learn some patterns, learn some trends. I highly recommend having it with you or when doing homework, and you should always have a periodic table out in class when we're doing stuff in class. Also, like your freshman year, you do need to memorize a list of element names and symbols. I would love to tell you know them all, but that's probably not the most fair, and I can't tell you for sure what AP will throw at you. I would say learning the first 56 is not a bad idea, but there's several up above that that you should know as well. The more the better, certainly. And early on during the school year, you'll have a quiz over element names and symbols. You'll also have a quiz over all this other extra stuff that's in this top region here, the bottom green box here, and the little green section over here. If you'd like some practice over the summer, in addition to just making flashcards or reviewing it however you may, there's a great webpage. Sporkle has just a lot of random quizzes. I shouldn't say all of them are great because by far they are not, but they do have a lot of decent element review games. The links are in the top as well as in the video's description down below. And the downside of this one is that it does require correct spelling, but you can see you can just start naming elements and it will fill out the periodic table for you. Of course, the other downside of this one is it has all 118 and you don't need to know all 118 for sure. So anyway, I will admit that when I'm doing this one and I get to one that I can't remember how to spell, I'll open up a new tab or a Word document and do a quick spell check. For example, Mendelevium, I'm sure I'm spelling wrong there, and here we can grab the correct version of it, and then I'll come back here and pop it in, and there it tossed it in down here for me. So you can use that for practice. They have several other quizzes that I also have linked. This one here is for practicing symbols when given the name, which is probably more useful. This one here is naming through the periodic table, name and or symbol. This one here is a whole bunch of names and just seeing if you recognize names. Nobelium, magnesium are elements. Planetarium is not. And this one here is coming up with the name from the symbol when given. So lots of different versions of the quizzes to practice from. Again, you don't have to practice with this site, but it gives you something to do and maybe something more fun than just reviewing flashcards over and over again. Links to all of these in the description below. Anyway, I'll spend a whole video talking about how to read this periodic table. Several of the other pages in your packet relate to this periodic table, so I'll gloss over those as we get to them as well. This one here is related to that periodic table. I'll come back to it when I do the video on that periodic table specifically. This next page here, or set of pages, is from David Katz, who's a chemistry teacher up in Canada and has the webpage chemist.com. Absolutely phenomenal resources available at his webpage, but he goes through some of the history of the periodic table real quick for you. I tell you, I'm absolutely fascinated by the periodic table. I have several great books on it on my bookshelves, and just read another great one this summer. But lots of good information about the history of the periodic table, some of the early alchemical symbols and how using symbols got started, Dalton's list of elements, and they were more lists at first before they are turned into table form, and then he goes through the basics of how symbols are determined. And for me, this has helped because it really helps point out why symbols are what they are, and so some of the weird ones begin to make sense. But for example, many of the common non-metals have one-letter symbols, hydrogen, boron, carbon, etc. So there are a handful of those, around a dozen on the periodic table that have one-letter symbols, and those are some of the easier ones to remember. From there, most elements are named the first two letters, so helium, He, lithium, Li, beryllium, Be, etc., etc. From there, if you start to get into places where the letters are reused, Ma for magnesium and Na for manganese, then they go for the first letter and first consonant, Mg, Mn. You see that repeated in the Cs in several places, chlorine and chromium being another example. Unfortunately, there are some elements whose names and symbols don't match. Fortunately, there's only 11. The downside is that many of them are very common: sodium, potassium, iron, copper, silver, tin, antimony, tungsten, gold, mercury, and lead. Antimony and tungsten are probably the least common of those in terms of being used in chemistry class, but tungsten's actually in any incandescent light bulb that makes up the wire there. He then has an explanation for the weird three-letter symbol ones. Those are only temporary names, and they don't really matter. If you want to read through why they're named what they are, there you go. I will say that elements 1, 12, 14, and 16 all have official names now, and it's only 1, 13, 15, 17, and 18 that don't have real names yet. He also, for some reason, leaves di for 2 and tri for 3 off of this list. But there you go. And then from there, he has just a list of names and symbols. He has the ones that he thinks are important for you to know. This is actually a pretty good list. I don't see any on here I would recommend not knowing. There might be a few others I would add to this list. The more, the better by far. You just need to be comfortable with seeing symbols and knowing the names and being able to jump back and forth between those two. You don't want that to be what's slowing you down in chemistry, because there's plenty of other things that could do that instead. Anyway, this gets into the charges on the periodic table, and it's called the monatomic charges, or the oxidation numbers. You'll notice the periodic table is arranged differently than your standard periodic table. This here is a more standard periodic table, as you can see. But this is the pattern that I taught you when you were freshmen. Column 1 here, everything has a +1 charge. Column 2, everything has a 2+ charge. We skip the transition metals your freshman year for the most part. The next column over here has a +3 charge, at least for the metals. The next column is ±4. You decide whether it's plus or minus based off of whether it's a metal like tin and lead, or a non-metal like carbon and silicon, although carbon does happen to be an exception to that rule, and carbon could be both plus or -4. And then from there, -3, -2, -1, 0 for the following columns, at least for the non-metals. So some of them can have other charges. Those are their standard charges, especially when in ionic compounds. And we'll get into a review of that later this summer and during the school year as well. The transition metals here all have various charges, as do many of the metals in the other metals section. Hydrogen, of course, can have a plus or minus 1 as well. Hydrogen happens to be an exception to many of our rules, and that's where this rearrangement comes in. They put the 0 column in the middle, and then you have all the minus charges to the left, all the plus charges to the right. The exception, of course, being the 4s here, which are plus or minus 4. That just has some of those charges. That's a pattern that you should know, have committed to memory, and being able to just know what the charge of an element is, at least by glancing where it is on the periodic table, if not actually memorizing its charges, phenomenal. This document has 3 pages, so I'll come back to the last page. It's page 8 in your packet. But again, just goes through the charges. This time they've just put the charge with the symbol, and he's included the transition and other metals that have a consistent charge. So there's only 3 transition metals that have a consistent charge. Cadmium is always 2+, zinc is always 2+, silver is always 1+. And so that is listed here specifically. On the next page, you'll see most of the transition metals have multiple charges. Now, this does not have all of them by any stretch of the mind. For example, vanadium has at least 4, and maybe more. I'm pretty sure manganese has 6 or 7 different charges that it can take on, and at least one of its charges is a negative number, which is very odd for most metals. But different charges that they can take on. There is an old naming system that used to name each of these differently, and we won't worry about that unless we need to this year. But for example, iron here, Fe, can have a 2+ or a 3+ charge. Copper can have a 1+ or a 2+ charge. And the metals that aren't listed here can have various charges as well. These are just the more common ones that we'll use more often. And we'll come back to the last page of this one here in a bit. So the next page is a flowchart, and this goes with the periodic table video that I will be doing later, as does this kind of. This is a list of the polyatomic ions. I think the video on the periodic table will explain how to name ions as well as how to name polyatomic ions and memorize their formulas and their charges very easily. However, if you prefer just to memorize them rather than memorizing the pattern is by far a shortcut, then here's a list you could start memorizing from. This is David Katz's list versus Etta Squardo's list, which is coming up here in a bit. Anyway, David Katz also has his own flowcharts for how to name compounds, and we'll do another video on how to name compounds another time. So we'll skip that page for now. These here, however, no matter what method you choose, whether you just choose to memorize polyatomic ions or memorize the patterns on the periodic table to determine the polyatomic ions, these are the exceptions. There are a lot of rules in chemistry, and one downside about rules is rules are frequently broken. Laws in science are set in stone, they cannot be changed. Rules, on the other hand, can be broken. There are exceptions to almost every rule, and these are the exceptions. These are polyatomic ions you just have to have memorized. Also down at the bottom, he has a list of common names for certain substances. Water should be obvious, H2O, but that's not a chemical name. Hydrogen peroxide, again, is not really a chemical name. H2O2 is its formula, so on and so forth. These ones here, as it says at the top, just have to be memorized. If you are a flashcards kind of person, that's what the next page is for. The next page has the names of the polyatomic ions. On the back there, formulas and charges of those same polyatomic ions. It should have copied correctly, so that cyanide, if you flip over behind it, is CN1-, and you could just cut it out and make your own little flashcards like that, or if you prefer instead to make your own flashcards on something sturdier, then you can use the information on these to make those flashcards. I just wanted to give you the resource since I had it. This next one here, I shouldn't have a digital copy of, but I do. It comes from Colin Purdyworth's webpage here, and he down at the bottom does say, please cite this and please don't keep your own copy. I had trouble accessing it at one point, so I ended up saving a digital copy of it. But it's an absolutely phenomenal article on how to maintain a good lab notebook. In AP Chemistry and dual enrollment chemistry, you will have to keep a lab notebook. You must write in pen in it. You cannot write in pencil. You cannot change anything. You can cross stuff off if you make mistakes, yes, but you cannot change it. Many universities will require your lab notebook as part of getting your AP credit, and you absolutely have to have this. It has to be bound so that pages aren't easily inserted or removed, and that again is for security's sake and making sure that you're not falsifying data. Not that that's a real concern, but we do want to establish good scientific practice and do things like real scientists. What I like about this, though, is in addition to just saying why you should have a lab notebook, he goes through some very good things about maintaining it, about how to mark in it, how to write in it, but he also turned it into an experiment. He took and said, okay, what writing utensil is the best for my lab notebook? And you can see here, he subjected them to erasing water, and water spills in the lab are very common. Heck, splashes from the sink are very common. 3 different solvents that are common in the lab, and even baked them to see how they held up under heat. I happen to be glad that the Pilot G2 pen that I use holds up fairly well, doesn't seem to bake too well, and it could do better under the solvents. But considering it's cheaper than some of these other ones that work really well, I was kind of excited to see that the pen I already used works for this. But it is something to consider, at least. But I like how he took something so simple, and you want to think of how do you keep a lab notebook scientific and turn that into a scientific experiment, but here he did. And it's nothing incredibly exciting, and yet it proves a very good point. And he then has some other tips and some advice, and I have read this article several times already since I originally stumbled across it, and I highly recommend reading it and then going ahead and setting up your lab notebook to be your own. We'll be doing at least 22 labs if everything goes according to plan. The last thing in your packet is the AP formula page and periodic table. When you take the AP test, if you take the AP test, this periodic table and this data table here will be available to you. This data table is barely useful at all on the test, honestly. It's a few questions will relate to this table, but they give you the whole table anyway. You're allowed to use those the whole test. The next 2 pages are formula pages, and they only allow you to use those on one part of the test. It's not to say that there won't be calculations on the multiple choice portion of the test where you're not allowed to use this or a calculator. There will be calculations on that section, but the calculations are simpler and they expect you to know the formulas. When you get into using the answers from part A and part B, C, and D, then you're allowed a formula page, and that comes in the kind of essay/free response section of the test, and that's where these last 2 formula pages are. We'll get to all these this year, and they will make sense to you once we get to them, but that is the AP formula page. When it comes to taking test in class, I'll be giving you this for the whole test most likely until we start doing practice AP test. Then we'll go ahead and follow AP rigors and only let you have the periodic table and the data table for multiple choice, and only let you have the formula page for the last portion of the test. Lastly, the letter at the beginning that I didn't read over does mention calculators. Math in your head is phenomenal, and I challenge you and myself to do as much of it in your head as possible, but you will need a calculator for this course to do the homework and for taking the AP test. Graphing calculator comes highly recommended. A scientific calculator is an absolute must. You have to be able to do multiple powers, square roots, and logs and natural logs. Anyway, a video about how to use Ed Esquarto's periodic table and some of the documents that I glossed over will be coming up. And if you have any questions, be sure to connect with me on Facebook, Google+, or in the comments on the video down below.